Beautiful.
Beautiful.
A gentle kiss to the earth and a safe landing.
Absolutely.
No kiff.
I want to welcome back all of our listeners to yet another episode of Bombshell Bodcast. I am your host, Andy Bowers.
And I'm your other host, Madeleine Roberts.
I'd like to introduce our wonderful guest, William Bobadilla.
Yes, sir. I'm a local airframe enthusiast, and I'm here to talk or present to you guys today of the new transforming airfoil.
Yeah. And as a quick little introduction for some of our viewers who are unaware, an airfoil is what is basically an aircraft wing, and it actually produces the lift for the aircraft. So it works by having a camber, and this camber is basically this shape pushes the air that goes above the airfoil faster than the air that is pushed below the airfoil. So this air, literally, because of the difference in pressure, it lifts the aircraft up, and that's where lift comes from. Additionally, some terms that you're going to hear throughout the episode is camber, as I said before, and chord length. The chord length is just literally the length of the airfoil from the tip to the end of it. And this usually these airfoils are static. They're structurally sound, and they don't all this the camber and the chord length are all static.
Okay.
And then if you're changing the camber or the chord length to the wing, that will obviously change how it reacts to the air, and it generally, in most cases, to be beneficial, it'll help decrease the turbulent flow over the wings and make it a lot closer to a laminar flow, because we all hate turbulence. We don't want that.
Absolutely.
And it'll help with efficiency during the takeoff and landing of a plane as well.
Mm-hmm. So,
Of course. So today I'm bringing to you the cutting edge design in aerospace. What you can see on the right is a transforming airfoil in Creo. Now, today we 3D printed that airfoil, and you can see this is the result. It is called transforming airfoil. Now, what's unique about this airfoil compared to the static ones Andy showed us is that it's capable of stretching, compressing, and also bending. Now, the benefit is that it can manipulate its camber and chord length. But when it can, due to its ability to bend and stretch, you can increase your angle of attack and increase your lift capacity as well.
absolutely, that's very, very important. I'm guessing is it takeoff and landings also? Is that important?
Yeah, so you can take off more efficiently as well. So that's really important. So when you take off, you can have this more efficient design. And then once you reach cruising altitude, you can go to a more traditional design.
Okay. And so, could you think of anyone who might actually find this design interesting?
Ooh, I think the Air Force's deep pockets definitely could have a home for this new design, specifically with the Air Combat Command. Now, we've identified one large deficiency that the Air Force hasn't recognized yet, and if you would please. So, as you can see on the left, those are two of the larger drones the Air Force operates. Now, one would assume that a smaller aircraft such as the Predator on the top would be more efficient, justifiably more efficient than, say, a Boeing 767. Andy, how much runway do you think a 767 needs?
I'm guessing ballpark around 8,000 feet.
Maddie?
I'd go with 9,000 or 10,000. It's a big plane.
Wow. Well, actually, it only needs 6,300 feet.
Only. Okay.
Only. I mean, that's pretty efficient. But I mean, what a drone? How much do you think?
I'd say only a few hundred.
A few hundred, maybe let's say 1,500 at most.
1,500. Well, it would shock you that takes 5,000 feet of runway to take off.
You're kidding.
No, and it's unmanned too. That's government efficiency at its finest. Oh. So the Air Force could benefit from adopting a transforming airfoil design for their drones specifically alone, so they can be more efficient.
Absolutely.
Yep. Operationally, of course, the military is going to have greater logistics problems given that the airfoil is having more moving parts, the normal things. But the the benefits will outweigh the costs.
Oh, that's
Okay. Now, well, posing a hypothetical for you.
Okay.
Say I'm a stockholder at Charlotte Douglas International Airport, just off the top of my head. How can I increase my profits in the company?
Well, by adopting our transforming airfoils, I can put more money in your pocket to say, visit France, get that croissant in 2 ways. Very easy. So how we're going to do this is decreased maintenance costs and increased operational efficiency. Now, with the transforming airfoil, it can create a much better lift to fuel ratio. So you'll be burning less fuel, and you can have more airplanes taking off in faster. So you can have more planes in the sky, more money in your pocket, and because it's more efficient, maintenance costs will go down.
That's nice.
So you can get that extra croissant.
So
Yes,
I'm
very
guessing the lower maintenance cost also decreases the overall cost of the airport, correct?
Oui.
Ooh, trade me
That
in.
is a lot more
Wait,
money
trade
in
me
my
in.
pocket. But should I worry about investing in this?
Well, there might be a little sticker shock, but if you ever heard the saying, buy once, cry once. So buying into this transforming airfoil design, now while you'll have to get FAA certified on all the different, changes,
Of course.
it will pay for itself.
That's what I like to hear.
Yes.
I like to hear profit.
We like to hear we like to hear certainty on the show.
Yes,
Absolutely.
I can guarantee it's worth the money.
Awesome.